that explanation would be a little bit more complicated, but the rule works the same way, whether you have negatives in the exponents or not. If you remember this rule, it'd be easier to get the answer here than doing all this work. And doing all this work down here. I think I was off the screen. Okay, so moving on. We need to do the power rule now. Power rule. Power rule. Okay, remember, power rule is when we're dealing with multiplying a power to a power. Power to a power. Power to a power. So when we're having an exponent and we're raising it to another exponent. We have the exponent a to the m, and we're raising it to the nth power, whatever n is. I'll color these in so they look nice. Another thing I needed to note here too is the same thing here, and this is where students often make mistakes. When I wrote this as an variable, I can write it as a to the m n. That means m times n. But if I go to write it with numbers, I have to make sure I use a times sign, either the dot or an x. Otherwise, you'll see when we do examples, you can't just put the numbers next to each other, because that doesn't mean multiply. It only means to multiply when you've got variables next to each other. All right, let's look at the notes on the inside. This says to raise a power to a power, you multiply the exponents. And I wrote out a little explanation here of what power to a power means. Power to a power is not the same thing as multiplying two exponents by each other. Remember, we should look at our examples. That's not the same thing as multiplying a to the m times a to the n. You see the difference? On this one we have to add, on this one we have to multiply. Why? Because a power to a power means you're solving the exponent to standard form and then raising it to another power. So looking at our examples here, if I wanted to just do this out without using our exponent rules, I'd have to find out what 3 to the 5th power is first and then raise it to the 3rd power again. All right, let's use our rule first though to do it the easy way, to find out what this could also mean. It says to do a power, you multiply the exponents. So we keep our base, always keep the base, 3, and then multiply the exponents, 5 times 3. 5 times 3. That becomes 3 to the 15th power, because 5 times 3 is 15. Now why does this work? Well, I've taken what's inside this parentheses and I've done it 3 times. I've multiplied by itself 3 times. So that is the same thing as 3 to the 5th times 3 to the 5th times 3 to the 5th. And if I expand those out, I'd have 5 3's here. So 3 times 3 times 3 times 3 times 3 for this one to expand. For this one to expand, I'd have to do it again. 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ugh, and I have to do it again, and I'm running out of room. 3 to the 5th. Another 3 to the 5th. 3 times 3 times 3 times 3 times 3. Oh, I squeezed it in there. All right. If I count those all up, I end up with, it should be 3 to the 15th power if I put in the right numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, squeeze that last one in. Remember, this is taking what's inside the parentheses and raising it to an exponent. It's finding this answer and raising it to the 3rd power. So to do it again down here for y to the squared to the 5th, and that's how you'd read it. Y squared to the 5th power. We always say power to a power, so the power to the other power. All right, let's keep our base, and this time we're using the variable y. We have to multiply the exponents, 2 times 5, and we have y to the 10th power. 2 times 5 is 10. So y squared to the 5th power is the same thing as y to the 10th. Let's show it out again, just like we did up here. We have to do y squared times itself 5 times. 1, 2, 3, 4. Y squared times y squared times y squared times y squared times y squared. If I expand each one out, I have y times another y times 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 y. That becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 y's. Y to the 10th power. See why it works? Okay. All right, and the last one. 0, 1, and negative exponent rule. I've explained a lot of this already in the rest of the video. But we put them separate so that you can easily access them to understand what they are. All right. Anytime you have an exponent of 0, it always equals 1. So if I have 4 to the 0, looking at our examples, 4 to the 0 equals 1. 10 to the 0 equals 1. 9 to the 0, 1. 565 to the 0, 1. Does not matter what the base is. It could be a decimal, it could be a negative number, it could, well, that might affect it. Negative number, a fraction, it could be any number. Doesn't matter what number that is. If it's raised to the 0 power, it will equal 1. If you don't believe me, plug it into your calculator and check it. Okay. Anytime you have an exponent of 1, it just means that you keep the base because you're not multiplying it anything. 4 to the first power just means 4. I'm not multiplying it by itself any more than once, so it's just 4. You haven't multiplied, you haven't done anything. So 4 to the first power, 4. 10 to the first power, 10. 9 to the first power, 9. 565 to the first power, 565. Again, does not matter what the base is. It could be a decimal, it could be a fraction. If it's raised to the first power, you haven't changed anything, it's still the same. Because I had a math teacher who told me that it was invisible. That first power was always there on any whole number. You can just imagine it there. You can add it in at any time and it doesn't change anything. Okay. And the last one, if we have a negative exponent, it can be written as a fraction using the reciprocal. Meaning I need to put the exponent in the denominator. So 4 to the first power goes on the denominator, and a numerator becomes 1. I've flipped it. What I've done is I've taken 4 to the negative 1, put it over 1. So I'm going to put a little explanation over here. I've put it over 1, and then I've flipped its places and taken away the negative. That's how you get rid of the negative. Okay, this is the answer here to that one. It works the same if it doesn't matter if the exponent is 1 or 50 or whatever the exponent is, that exponent stays what it is. I know in all the examples so far we've only used to a negative 1 as the example, but if it's any other number, that number has to stay there. So negative 5, flipping it over would become, we put 10 to the negative 5 over 1, we flip it and get rid of the negative, so it becomes 1 over 10 to the 5th power.